Hello everyone, it's Miss Thomas, and this video is graphing functions. So in order to graph functions, we need to have some of the language of functions sort of sorted out and clear. So the first term that we need to be clear on is the independent variable. So the independent variable is the variable that provides input values. Its value does not depend on the value of other variables. So time is often an independent variable because time continues on. Things change over time, but time continues regardless of what else is going on. So conversely, we have the dependent variable. The dependent variable is the output function's values of a function, and its value is the result of a change in the independent variable. Your height is an example of a dependent variable if you think about your height over the course of your childhood. So time would be the independent and your height would be the dependent. Another important distinction to make in graphs are discrete graphs versus continuous graphs. So for a discrete graph, you're talking about a collection of isolated points where the values in between are not possible. So you might have something like let's say the number of tickets sold. If each ticket costs $10 and the revenue and in this case, if you sell one ticket, you're going to make $10. If you sell two tickets, you're going to make $20. You can't sell a half a ticket, though, so you can't have a connection between those. So while the relationship is linear, it can only take on these whole number values. Whereas continuous, there are no breaks in the graph, and there are infinitely many values in between any 2 points, which is hard to think that there could be infinitely many, but we can have the same relationship so let's think about age in months of some animal. And their weight in pounds. Sure, they can be 1 month and 10 pounds, and 2 months and 20 pounds, and 3 months and 30 pounds, but they could also be 1.5 months and 25 pounds, or 1 month and 1 day and just a little over 10 pounds. So there's all sorts of values that can exist between the whole number values. So that's really more of what a continuous graph would look like, is that you can imagine, sure, there's 2 months and 3 months, but there's also almost 3 months, and they're almost 30 pounds. So there's all sorts of values within the whole number values as well. So we all have all sorts of functions that we're going to graph in this course and throughout your time in high school math. And we really want to address what's really our fallback for graphing functions when all else fails. You're going to learn lots of tricks and shortcuts. You probably already know some for linear functions. So we're going to look at some unfamiliar functions. The first function that we are going to look at is going to be an absolute value function. So I'm going to say graph y equals the absolute value of x plus 3. So this, we don't really have a trick for this yet, So whenever you are faced with a function you're unfamiliar with, go ahead and make a table of values. And for a lot of people, it actually helps if you have a section of your table of values where you show the work, so you can kind of stay organized. And when you're choosing your inputs and your outputs, go ahead and choose a wide range. So we're going to do -5, -4, -3, -2, -1, 0, 1, 2, 3, 4, 5. And because this is a really unfamiliar function for us, that's why we're choosing such a long list. We may not always need to choose such a long list as we get more familiar with our functions. But we just want to make sure we're going to go ahead and plug that absolute value -5 plus 3. So just like in order of operations, we're going to take the absolute value first because it works as a parentheses. So it would be the same as 5 plus 3. So this is going to be a positive 8. Absolute value of -4 plus 3 is the same as 4 plus 3. So this is going to be a 7. This is going to be a 6. Plugging it in, absolute value of -2 plus 3 is going to be a 5. It's going to be a 4. Absolute value of 0 plus 3 is a 3. It's a 4. Absolute value of 2 plus 3, 5. So you kind of see a pattern going. It's going back up. So we're going to want to go ahead and make a coordinate plane. So we'll just start okay. And make sure you label your axes. So I'm going up by 1, so I really just need to indicate that I'm going up by 1s. And then I can go ahead and start plotting my points. So there's -5, 8, that's the coordinate -5, positive 8. So I'm going to go back, -2, -3, -4, -5, and then I'm going to go up 8 from there. And this is definitely where graph paper comes in handy. And then for the -4, 7, I'll go back to my -4, and then I'm going to go up to positive 7. 3, 6. 2, 5. 1, 4. 0.03, just in case you're losing track, this is where we are right now. 4 needs to come down a little. And then as soon as I get back to positive 1, I'm at positive 4 again. Two, 5. 0.36. 0.47. And the 0.58. And so generally, unless there's some indication otherwise, we assume that a function is continuous. So an absolute value function actually forms a V, And again, unless there's some restriction stated, it will continue infinitely in both directions. Okay, another example that we are going to do is we are going to graph y equals negative 2x to the third. So pretty simple. So I'm going to go ahead and make that table, that extended table of values again. I'm going to start at negative 4 this time. Oops. Oops again. Okay, and so I'm going to just go ahead and substitute each of these values in for x. Okay, so it's going to be negative 2, negative 4 to the third. So keep in mind your order of operations. You are going to need to go ahead and take care of the negative 4 to the third, and then multiply that times the negative 2. And negative 4 to the third is going to be a negative 64. So then taking the negative 2 times the negative 64, I am going to get a positive 128, which is huge. But obviously the higher the exponents go, the bigger our numbers are going to become. So I'm just going to go ahead and repeat this. So this line, negative 2, plug in a negative 3 for the x. So 3 to the third, well, negative 3 to the third is going to give me a negative 27 times 2. It's going to give me a positive 54. So we've already come down more than halfway. So negative 2 times negative 2 to the third to negative 8. Negative 8 times negative 2 is going to be positive 16. Oops. Negative 2 times negative 1 to the third is going to be a negative 2 times a negative 1. So it's going to be a 2. Negative 2 times 0 to the third. It's going to be 2 times 0, so that's just going to be a 0. Negative 2 times 1 to the third. It's going to be negative 2 times 1. Negative 2 times 2 to the third. And so you may see a pattern that's starting here in that it again is starting to mirror those images, those values, only this time we're going to turn into negatives. And so that pattern is going to hold because we're doing the same operation to the base. It's just in one case that base is negative, in the other case that base is positive. So I'm just going to go ahead and know that for my 3 is going to mirror this, only be negative, negative 54. Now my 4 is going to mirror my negative 4 and be a negative 128. But just be careful, it doesn't always match up with the same input value that it. So we're going to go ahead and graph. I'm going to start by graphing my 0, 0 first, partially because it's easiest, but partially because my extreme values really go high. I am going to make my axis by 2, 2, 4, 6, and that'll let me fit at least a couple more points on here. So the next point I'm going to graph is going to be my 1, negative 2, So 1's going to be halfway between the 1 and the 2, but at the -2. And then I'm going to graph my 2, -16. So 2, and then 2, 4, 6, 8, 10, 12, 14, 16. Then I'm going to work my way back up because I'm certainly not going to graph my 3, -54. So I'm going to go ahead and graph my -1, +2. So I'm going to be halfway between the 1 and 2 and at +2. And then -2, 16. 2, 4, 6, 8, 10, 12, 14, 16. So, you may notice this does not form a straight line. I mean, your gut may want to say straight line, but it's not a straight line. What actually happens on this, it is a curve. It comes down pretty rapidly. And then it sort of swooshes over and comes back down this way. It's pretty ugly through here. So there's this nice curve in here, almost like a curve in a road. And then this graph is going to extend on forever. Okay. So now it's time for the U-try. You have 2 U-try problems. The first U-try problem is y equals the absolute value of x plus 1. And your second U-try value is y equals x to the third minus 2. And just to be clear, what you are doing is graphing both of these. So I look forward to seeing what your graphs look like. Just try your best. And I'll see you tomorrow.